Hey everybody, welcome to Security Automation using AWS Management Tools. I'm Will St. Clair. I'm a Senior Solutions Architect with AWS, covering public sector customers. I've been with AWS for about 3.5 years, and this is my 4th Public Sector Summit. So welcome. I'm excited to talk to you guys today about how to kick off some automation processes in your environment using our set of automation tool or management tools. This is a pretty broad topic, and I've tried to condense it down to 50 minutes. Get as many demos in as possible, console walkthroughs, so you can actually see how these services are configured, how they come together. So I'm just going to go ahead and get started. So on the agenda today, I'm just going to talk about at first how to classify workloads and define controls really quickly. Then I'm going to go into some information on how to provision and baseline your environments, particularly in a multi-account environment. How do I ensure each one has a security baseline? How do I provision that automatically? Then we're going to securing and monitoring the properties of your actual AWS environment yourself. Then I'm going to talk a little bit about how to secure and monitor your workloads using some new AWS services. And then finally talk about how to respond and automatically remediate conditions in your AWS environment. So if you do have something that falls out of compliance or something that's not in line with what you want, how do I remediate that automatically? So let's start with classifying your workloads. So I like to think about, if you're familiar with the federal compliance frameworks, this is a similar concept. Think of 2 axes for the impact of your workload. On one end you have your confidentiality, and the other end availability. These workloads could be individual applications, they could be individual developer environments. I'm going to advocate for this as sort of the boundary for your AWS accounts. And what you want to do is you want to classify these based on their impact. So down in your lower left, you have individual dev tests. Maybe as you go up in availability risk, you get things like low-risk apps or team dev test environments. Up here, high availability web stuff, but not necessarily high confidentiality. And then sort of down on the right, you have analytics on sensitive data. Moving up to sensitive internal applications, and then you have your critical applications that need to share sensitive data, but potentially with external stakeholders. So you can break this down into as few as 3 or 4 quadrants. You can break this down into 9 quadrants. But the key concept is obviously that controls are additive, right? If I have a set of security controls that I have to build on, I'm going to define how I want to implement those in terms of code and configuration. And in a low-risk environment, I might just have a handful of essential controls. That's going to build up into my medium-risk environments, and then further on into my medium, high, and high environments. So the work that you do at the lower levels helps build your repertoire of controls, repertoire of tools, et cetera, as you start moving more and more sensitive, more and more critical workloads into the cloud. I like using AWS accounts as impact and workload boundaries. This is something that's really been enabled with AWS Organizations, which I'm going to talk about in a little bit. But this AWS account is obviously the highest level of isolation between resources within the environment. If I create an account, you create an account, those environments are separate. If you create 2 accounts, they're as separate as you want them to be until you explicitly set up trust relationships or explicitly set up network peering relationships between those accounts. So as you're sort of identifying workloads to move out of an existing infrastructure, think about how I can break those down into AWS accounts. You don't want to necessarily get too fine, with the databases in one account and the web servers in another account, but you don't want to get too coarse either. There's no reason to have a single massive account that has all of your medium or all of your high workloads in it. You want to take advantage of that isolation when you can. So let's talk about how you provision and baseline those environments once you actually get up and running. So AWS Organizations is some newer functionality that allows you to have policy-based management for multiple AWS accounts. I can create a single master account and then create new AWS child accounts under that using the Organizations API or the console. I can organize accounts into groups, organizational units, and then I can apply policies that apply to each one of those groups. So if I want to restrict the services that are available, for example, I can do that within a individual subunit. And obviously, I can also consolidate the bills for all my accounts in my organization and use a single payment method. So if I look at the lifecycle of an AWS account, I'm going to start with my master account. I'm going to identify a need to create a new account. Maybe that's a developer that needs to do dev test environment. Maybe this is a team that's wants to host their continuous integration pipeline. Maybe it's a production account for a new service. I'm going to provide some sort of questionnaire, single point of entry to determine classification, security risk inherent in this account. I'm going to provision that automatically using the organization's API. Apply a security baseline to that in accordance with the classification that we've determined. And then as part of that, monitor and respond to incidents in that account using the implementations of the controls we've defined. And also periodically review and rebaseline. I should have a database or spreadsheet of who owns which accounts. If someone leaves, obviously someone else needs to take that account over, and I should be periodically asking them to reattest to what's in that account, making sure that stuff stays in compliance, and if the account is no longer needed, it's closed. So what's in a security baseline for a new account? AWS Cloud Trail, audit logging for AWS API calls is critical. Identity and access management configuration, things like roles and managed policies, determine the access permissions that people have in those accounts, any trust relationships to identity providers, et cetera. AWS Config, so this is going to allow us to create config rules. AWS CloudWatch, talk a little bit about CloudWatch events and config rules later on. And any VPC configurations. And additionally, anything like flow logs. So typically, what we would use, and if you were in Chuck's talk last session, you got the deep dive on CloudFormation, but CloudFormation is how you would template out and deploy these security baselines. CloudFormation is a service that provides a common language for describing, provisioning all your infrastructure resources. You create a template using JSON or YAML. You can either deploy that template all at once, or this is the preferred workload now, is to use change sets to create an individual change set or diff. And then deploy that into a stack. Once a template's been deployed, it's realized into a stack, and all those resources belong to the stack. So there's two ways to distribute standardized configurations in CloudFormation in an environment like this. You could obviously deploy them manually, but when in a multi-account environment, you want some way to automate that. So first is CloudFormation stack sets. This is what I like to call the push model. I, in the master account, create a set of templates or template that defines the baseline configurations for a particular classification level, and I can actually go through and push all of that, push those templates directly to the regions I want and the accounts I define. Another way to do this is maybe a pull model. Maybe I have a library of approved templates for particular workloads. Maybe if someone creates an account, they won't necessarily need a virtual network. They can pull that when they need it. Or maybe I have a standardized configuration for a LAMP stack or another application. In here, you can use AWS Service Catalog to do something very similar. I can define the templates in the master account. I can create products out of them in Service Catalog's lingo, delegate the permissions, who's allowed to access them, and then those end users can pull them. So I have a quick demo to talk about how to create new accounts in your organization and baseline them using AWS stack sets. So I'm just going to navigate here to the CloudFormation console. Go ahead and create a stack in my master account. The stack I'm creating in my master account is simply just to create S3 buckets. And this is going to be where I'm going to collect Cloud Trail logs and configuration snapshots for all my child accounts. So this is just sort of a prerequisite. Have a little movie magic here to speed up the process. But all this is doing really is creating those two S3 buckets. Now I'm going to go into AWS Organizations. This is my master account. So I'm going to create my organization for the first time, enable all features. If you have a legacy consolidated billing account, this would be a step you'd have to go through. Going to hit Add Account to create a new account. I'm going to create 2 accounts in my new organization just to demonstrate some multi-account deployment functionality. I'm using the console here, but this is also something that you would almost certainly want to automate using the command line or the API, depending on what your own service fulfillment practices are now. The console is convenient, but it is, and it's a great way to explore the APIs and get used to it. But this is something I definitely like to make part of a workflow, integrated with maybe your ITSM or help desk ticketing system, whatever process would be most appropriate to onboard users. So I've created my 2 child accounts here. And I'm going to organize them into, record their account numbers. Obviously, this is something where you want to make sure that this is being cross-referenced in a database, who owns this account, if the email address, email address changes. And I'm going to organize them into an OU called security baseline. Just go ahead and move them up here. Obviously, like similar directories, you could get as fine or as granular as you want, different departments, teams. I'm going to record the OU because I'm going to want it later, or the OU ID there. So now I'm going to go to CloudFormation because I want to deploy a baseline template to these accounts. I'm going to change my context here to stack sets from the main stacks configuration. The template I'm deploying is fairly straightforward. All I'm doing is just making sure that Cloud Trail is turned on in the destination accounts and that config is turned on in the destination accounts, and that they are reporting those logs and those snapshots back to the master account. So this is the name of my stack set. I'm going to set the config delivery frequency to 1 hour. And then this is just the names of the buckets I created as part of that CloudFormation template, the first step. And so this is actually, I'm going to pause. You can specify the accounts you're deploying the stack set to. In this case, I'm actually going to deploy the stacks based on the organizational unit. So I don't need to add up all the account numbers or import that manually. All I have to do is specify the OU of the account of the ID of the OU I just created. Again, I'm just going to deploy this to all regions, make sure I'm capturing all configuration occurring in all regions. I've created a role to deploy those stacks out that CloudFormation will assume, and then the role it will be assuming in the target account is the one that was created with the organization. So now we can see, these are all basically the templates that will be deployed. I have 2 accounts here across all of our regions. So they're all status outdated. We haven't deployed the templates yet. And again, through a little bit of Hollywood magic, we will start to see these templates get deployed, across all of our regions worldwide. And so now, once this finishes, I'm going to see what's happened. So we're going to go over at S3. And what we should notice is that we won't have data from all regions yet, because this took a while to deploy. But we should be able to see that the Cloud Trail bucket is starting to aggregate Cloud Trail and audit logs from all of our accounts in all of our regions. So you can see here that Cloud Trail has created its initial log entries in your first couple accounts. And we're also going to make sure that the same is the same for config. All right. So we've provisioned and baselined our AWS environments, but I haven't talked a little bit about what Cloud Trail and config actually are. So Cloud Trail is sort of the very most basic of security controls you want to deploy. This is going to be an audit log of all of your API history. So this is actions taken through the console, through the SDKs, through the command line tools. This is an audit log of what's happening in your accounts, and something that's going to be critical just for monitoring who's using what, as well as for security incident response. Cloud Trail can record to an S3 bucket in the account it's configured in, or it can be pushed out to a bucket in a different account, which is what we were doing in that demo. So use cases for Cloud Trail, obviously meet compliance controls, gain visibility into IAM user activity. You may want to push this into a log analysis system so you can alarm on things like people logging in, doing things at odd hours, stuff like that. Maybe you want to detect access to APIs or data from IP addresses. I know which IP addresses users should be using if they're logging in from the corporate network. If I see stuff that's outside that, if I see stuff from other countries, that's stuff that's automatically suspicious. Or more mundanely, I need to troubleshoot misconfigured permissions or applications. There's obviously a lot of access control in AWS, and you want to make sure that when you're troubleshooting, you can go in and see, oh, this was denied because this role did not have the correct policy, et cetera. Best practices, you want to make this as part of your security baseline. You want to make sure that you're aggregating events from all regions, and that you're logging to a single S3 bucket in a central account. This means that if an individual sub-account is compromised, that you're not putting the log data at risk. Use AWS KMS encryption to encrypt that log data, validate, have validation enabled so that you can go through and validate that, and then log both management and data events. So management events are things like API calls, and data events are things like S3 access logs. You can integrate with CloudWatch logs to create derived metrics. So what this means is, in addition to just consuming the files out of S3, you can push that to CloudWatch logs, which gets you some functionality in terms of being able to filter and search, as well as to say, I want to pluck this field out and create a metric out of it. So how many times is this API being called? If this API is being called once in a 5-minute period, I can alarm on that built in without having to build the parsing myself. And use CloudWatch events to report high-value events to ticketing your chat system. So if you are using Slack or HipChat or something like that, you can create CloudWatch events that are listening to Cloud Trail events and then push that right into chat, which is good for just day-to-day visibility. Next thing we configured was called AWS Config. So Config is a continuous recording and continuous assessment service. If Cloud Trail is what's logging what was done, Config is logging what is. It's creating snapshots of the current state of your configured resources. So you need both of them. You could try to reconstruct the current state of an environment from just the Cloud Trail logs, but it'd be kind of messy. What Config gets you is an actual snapshot of the configuration changes that you make to your AWS resources. This is done in a machine-readable JSON file, but you can also take action on that by setting config rules that determines whether or not an environment is in or out of compliance based on the state of that configuration snapshot. So as resources change in your environment, AWS Config is monitoring them and gets notified. And from there, you're getting these configuration snapshot files. These configuration snapshot files are super useful, particularly in terms of what you can do with them with a log aggregation system. This is going to contain things like all of the instances in my environment, what are their IP addresses, what security groups, firewall rules do they have. One thing I've seen customers set up is I want to turn this into a search, push this into my log search index so I can pull out all the IP addresses I know I own, so that when I'm searching through my logs, I can exclude them or see if they're turning up in weird places. From there, AWS Config Rules can parse those snapshots and return some sort of compliant state. Or you can push them into AWS S3 for, like I said, additional outside analysis. Config Rules allows you to create rules which define reflect the desired state for the environment and then alert when those change. So you can choose from built-in rules, which I'll demonstrate in a moment, or write your own using AWS Lambda. These are things as simple as, are my EBS volumes encrypted? Do I have S3 buckets open to the public? Is there outdated software running on my instances using Systems Manager? Are my RDS instances being backed up? What's the age of my oldest snapshot? And you can take that and produce sort of a red-green status on whether or not my environment is in compliance. This is a newer feature. You can also aggregate rule compliance from multiple accounts in multiple regions and see that on a single dashboard. So you can see that this environment is in a little bit of trouble. Looks like a few rules are in compliance, but for the most part, things are out of compliance. Best practices. Again, same as Cloud Trail, deliver config snapshots to a single S3 bucket. Parse out key information, resource IPs, host names, AMI IDs. This is going to give you information of what the current state of my environment is. And then use CloudFormation and StackSets to automate the configuration and deployment. So let me go and show you my second demo. So in this case, the first template that we deployed Cloud Trail configuration, config configuration, but it also deployed a config rule that determines that reports whether or not Cloud Trail is configured in the target environment. So what we're going to do now is set up aggregation so I can observe the compliance status of my different accounts. So here in the config dashboard, I'm going to go to aggregators. I'm going to hit add aggregator here to create a new aggregator. Again, I'm in the master account, up here in the upper right-hand corner. We're going to give Cloud Config permission to replicate data from that source account. We're going to name our aggregator. And again, I don't need to enumerate each one of my accounts. I have the OU that I created earlier, so I'm just going to pull everything in from my organization. I'm just going to create a role that allows config to get that data from organizations, sort of delegating that permission. And I'm going to pull stuff in from all regions. So again, this is going to start pulling in data from our other accounts, have a little bit of editing magic here. We can see that we now have 2 rules in compliance. These are the Cloud Trail is present rules in both of the child accounts we created. Now I'm going to go into one of my child accounts. We can see that we have that one rule. I'm going to go into rules. I'm going to create a rule. So in this case, I was looking for something that was relatively straightforward to demo. This is the selection of the built-in rules. Again, you're not limited to these. We have a repository of custom rules in GitHub, and you can obviously write your own. And so I'm just going to create a rule that says, the instance type, in our account should just be T2 micro. This is, we're pretty budget-constrained organization this quarter. We want to make sure that people aren't using bigger instances than they need to be. So we're going to go through and start that. The rule is going to be evaluating. It's going to tell me I don't actually have any EC2 instances, which is what I expect. I'm going to go through create an EC2 instance that is non-compliant. We're going to see here that in launch instances, someone's feeling a little like a T2 micro isn't quite enough. We're going to launch a T2 small. Go ahead and wait for that to create. Reload. All right, we're running. So going back to config, we can see that going into our rules, we're still seeing that the one rule is, it's present. So let me go over to my rule setting, reload. Okay, we now see that there's one non-compliant resource under desired instance type. We've created a small rather than a micro. I'm going to go back to my master account here and see that this data has been pushed up and aggregated. We also see here, this is just an artifact of the demo, the config rules for all of our other AWS, all the other regions in our child accounts have now fully aggregated. So we have 2 rules per, or rather 2 accounts, and then there's a config rule in each one of the regions that's specifying that Cloud Trail is active in that region. So that's why the amount of in-compliance rules has shot up. But we now see our one non-compliant rule for our desired instance type. Let me talk about securing and monitoring your actual workloads on AWS. So there's a couple things I'm going to talk about here. Systems Manager allows you to centralize your operational data from your actual instances running themselves. So on your instances, we have a few images that have the Systems Manager agent built in. This would be our Windows instances as well as our Amazon Linux instances. And what this agent does is allows you to plug into the management functionality in AWS. And what you can do there is define and maintain a desired state of not just the resources in AWS, but the resources running quote unquote above the hypervisor in the EC2 instances you control. You can take inventory, so I can once I have the agent installed on each one of these instances, I can inventory what's running on these instances, see if I'm seeing old versions of software, new software I haven't seen before, sort of management tools like that, as well as manage and update patches. I can select and deploy an operating system, patch baseline. I can, enforce a policy of what my, how long I want to wait after a patch is released before I roll it out to my entire fleet. And I can actually use Systems Manager to run commands on those instances that have the agent installed to update that to the appropriate patch baseline. Unfortunately, we're a little short on time today, and I'm not fully doing Systems Manager justice. So definitely check that out later. Next thing I talk about is a new feature we have, or a new product we have called AWS Secrets Manager. So if you've ever deployed or managed applications in production, the question is, what do I do with all the secrets that this application has? In AWS, we can provide EC2 key or AWS keys directly to an EC2 instance using instance profiles, but you often have other secrets and other resources as well. Things like database passwords, things like API keys to other services. Maybe even things like encryption keys or certificates. So you don't want to put those in the configuration. You don't want to put those in your source repository, and you want to be able to audit and secure them and make sure that end users or your engineers aren't seeing them, they're not being compromised. And you also want to rotate them. And so what Secrets Manager does is provide a full set of functionality for the lifecycle of a secret, from provisioning it to rotating it to delivering it to your applications and providing full visibility within that process. It has fine-grained access controls based on identity and access management, managed credential rotation, which I'm going to demonstrate in a second, and then built-in integration with Amazon RDS. So if you're using Amazon RDS, you can use Secrets Manager today to deliver secrets to your application and automatically rotate them. So I'm going to demo that. So what I've set up here is I have a couple hosts and a VPC, and then within that VPC I have an RDS instance, RDS PostgreSQL instance that's brand new. I've just created it with a master user, and that master user's credential is change.me. Obviously, that is not a desired configuration, so I'm going to set up the master user's password in Secrets Manager. So here I'm just going to set the endpoint of my database. Put the password in an environment variable, not a very good password. And then just set up the psql command to just connect to the shell really quickly. Again, I'm using the command line here, but this is equally applicable to your application. You'll see in a second that there'll be sample code for the AWS SDKs. If I'm using a Java application, C#, Python, Node. So we can see that the password has changed me. I can log into the shell. That's gross. So let's go ahead and enroll this secret into Secrets Manager. Just going to go into the console and hit Store New Secret. First option here is credentials for an RDS database, although if I had other types of secrets, I could do that here. Again, password has changed me. We're going to select the KMS key that we'd like to use. This could be, I'm just going to use the default here, but this could be a KMS key that maybe you've imported using custom key material. And all the normal features of KMS apply here. I'm going to create a secret name pg/master user. This is just the password for our master user. The namespace and slashes can be helpful in permissions. So what I'm going to do is I want to automatically rotate this. I can select an interval rotation from the dropdown here or create a custom one. It's a demo. We're going to have a pretty aggressive rotation schedule, 7 days. And I can choose whether I want to use this secret to rotate itself, or do I want to rotate this using a different credential, right? Like if I have, in this case, I'm storing the master user, so I'm going to use its own password to rotate it. So we're going to go through, check. This is the, just going through here, this is some sample code just showing you how you would retrieve this secret from the SDK, depending on which environment you're using. You're not limited to those 4 languages. This works with any of our SDKs. So we've created the secret, and it's going to actually set up and rotate the secret now. And so what this is actually doing under the hood is it's actually deployed a CloudFormation template from our repository that creates a Lambda function that sits inside the VPC of your database and performs the rotation using that Lambda function. So you can take a look at that Lambda function, base your own code off of that to rotate this. But there's no magic here. There's no privileged pathway that we've created to connect to your database and set the password for arbitrary users. You can reset the password user using the RDS API, but for other database users, this is all within the environment. This is all something you control. This is all something that gives you visibility. We can see that the Lambda function has been invoked by Secrets Manager. It's been invoked once. There are no errors, so hopefully our secret has been rotated. And you can see here in the network, it inherited the network configuration from your database. So these are the two subnets from the database subnet group, and this is the security group from the database. So you need to make sure that the security group the database has can connect to itself. So it says your secret's been stored. So I'm going to try to connect to the database with change me. It's not going to work. So now I'm going to try to retrieve the secret from Secrets Manager and pass that into the psql command to see if that's going to work. We may have forgotten to do something. So this here, I'm just where we set the password before, I'm just calling out using the subshell to the AWS command line. Again, this is a little gross. You'd want to use the SDK. You'd want to use your application. But it's a demo. So this is going to return a block of JSON. So I'm actually going to parse the password out of the JSON block that the Secrets Manager command line returns. So this is not critical, just how I implemented it. And this is our master user. We're going to connect to the Postgres database. And so we're actually not set up permissions yet. So we noticed that there are fine-grained access controls here. We need to make sure that the instance that I'm connecting to has access to the instance profile that can connect to this. So I'm just going to go in, edit my policy for this host real quick. Go in and then update the permissions here just to show you what a policy looks like that allows secrets access. So here we've set up a secret to set up the resources here for a pre-existing secret, but I've given it a different name, so I'm just going to go into the editor and change it to the correct one. You'll notice that 6 question marks on the back end. That's a wildcard for the resource name that Secrets Manager will create. Once you give it that sort of /limited path name, it's also going to postpend a little hex string to it. And that's to preserve the uniqueness of the ARN between maybe different instantiations of the same secret name. So if I delete a secret and it comes back, I don't necessarily want to allow the permissions on it. So if I want to be very precise about what secret I'm allowed, I can include the literal hex string there. In this case, I don't care if there's any secret in my account that has that name. I'm going to keep it. So that's what the question marks are. If I put a star there, it would allow any arbitrary text after that. So this is just to constrain it a little bit more. So I've reconnected. Access has been allowed. And so I'm just going to create a database. And I'm going to create a new sub-user, demo user. Demo user also has a very poor choice of password. Just going to grant privileges to that demo user on our demo database. So what I'm going to do this time in Secrets Manager is, in the first case, we created a secret that was rotating itself using its own credentials. In this case, I'm going to rotate demo user's password using master user's credential. Because I want to make sure that we have the correct audit, we're recording it with the right user. So again, it's a very similar process. Again, we're going to rotate this automatically. Just get 3 days. So in this case, I'm going to, rather than using the secret itself, I'm going to use the secret I've previously stored with Secrets Manager. Again, same sample code. And so this is going to be slightly different because we deployed the Lambda function, but we've not fully permissioned the Lambda function to access the source secret. So we actually need to, for security reasons, go through and explicitly grant permission to the master user's credential to that Lambda function. That's what we're going to do real quick here. So you just click on roll there to drop you right to the IAM console. Edit that policy. I'm just going to fast forward this. What we're doing here is we're adding get secret value to our master user. Review the policy, update it. Now we're going to, now that we've set the permission, we're going to rotate that credential. And now we can connect as the demo user using the freshly rotated credential. So that's Secrets Manager. So we've talked about how do I baseline and provision new accounts? How do I monitor my AWS configurations? What are some of the tools I have to monitor and secure my workloads? How do I respond and remediate? So let's say that in my config environment, something has come out of configuration, what can I do just besides emailing me and paging me, right? I get enough emails and pages already. So in some cases, you may actually be able to automatically take remediation actions. My favorite example of this is logging. There's a lot of different resources in AWS that need to have logging turned on. S3 buckets, excuse me. S3 buckets are one, elastic load balancers, CloudFront distributions. There's a lot of different services that throw off logs, and in most cases, you need to go through and turn that on manually because it could be high volume. You don't necessarily want to pay for it if you don't care. So we're going to use CloudWatch events. So what CloudWatch events does is, it gets information from different AWS services of events that have occurred. This is sort of different from configuration changes. This is more about when things happen. You can also use CloudWatch to manage scheduled events, so this is very similar to cron. And then I create event filter patterns, so I can say, I want to pick up on all EC2 state changes, or I want to pick up on everything from this timer that I've set. In this case, we're going to pick up on when a configuration resource or config resource has gone out of compliance. And then I specify an event target. Again, this could be something as simple as an SNS topic to send me a page. It could be a Lambda function. It could be a particular EC2 action I want to take. When I get this action, reboot this instance. Whole set of things and services that it integrates with. Maybe I want to kick off a step functions workflow. Maybe I want to create a queue message. Things like Elastic Container Service or AWS Batch. Maybe I want to kick off a build. So this is sort of an all-purpose event publish and subscribe system for platform events. In this case, I'm going to integrate with, new targets, AWS Systems Manager, AWS Inspector. And event sources. This would be things like API calls, scheduled events, and then service events. There's a wide variety of AWS services that we integrate with. Things like, as I mentioned, EC2, things like auto-scaling. Maybe I want to be notified when my cluster scales up and down. But in this case, I'm mostly concerned about how do I handle configuration resources. So let me demo that. So real quick, I'm just going to go into IAM here, and I like to show this for housekeeping, so that when you try this on your own, you understand what the policies and permissions are. In this case, we're going to allow Lambda. We're going to create a policy that allows Lambda to assume a role in a different account in order to modify the configuration in that account. So in this case, if we create an S3 bucket in another account, we want to make sure that if that bucket does not have logging configured, that we can go into that account and turn logging on. So this is very similar to what we were doing with CloudFormation, but I'm just going to create a role that allows Lambda to assume the roles in my child accounts. Rather creating the policy, now I'm going to create the role. In this case, we're going to have a Lambda function. So we've already created the policy. You're just going to select that, as well as the Lambda basic execution role. If you're less familiar with Lambda, what the basic execution role does is basically just allow the Lambda function to write to CloudWatch logs. So this is something that all Lambda functions have to have. And we're just going to call this Lambda remediation role. Now I'm going to set up the function to go in and turn logging on my S3 buckets. So going in, I'm going to create a function. In this case, we have example code in the application repository, but I'm just going to copy paste some example code here. We've already created our role, so we're just going to choose the Lambda remediation role. Hitting create function is going to drop us down into the code editor. So this is just to walk through the code a little bit. We're creating a client for the security token service. This is going to allow us to pivot to get credentials for the child account we want to operate in. And this is going to parse out the message we're getting from config. So in this case, if config is telling us that we've received a notice because an environment is now compliant, we don't care. We care about if it's not compliant. We're going to assume the role in the destination account. Then we're going to take that role, and we're just taking the credentials that we got from the API call, and we're using that to create a session for the SDK. And then down here at the bottom is our actual API call. We're just going to call put bucket logging on S3. So we're going to hit save. So the next thing we need to do is actually go into CloudWatch and create the rule. So in our parent account, we're going to do this in two places. First, we're going to create an event bus, which is going to allow the child account to publish events to the parent account. In this case, I'm just going to let everyone write permissions to this, although you can specify accounts specifically. And now we're going to create the rule that actually triggers on a compliance failure and invokes the Lambda function to remediate it. So in this case, we're choosing from service. It's a config rules compliance change. This is a special event to the service. And I'm going to only trigger or only pick up on this event if it matches S3 bucket logging enabled. So here's our event pattern. If you think of an event bus as every single event in the system passes through it, this is just defining which of those events we catch on. And then we're going to invoke a Lambda function, our remediate S3 bucket logging function. Just going to give this a name. And so this is just doing one thing, but you could catch as many different events as you wanted to here. You could catch all events. Maybe I have a pretty complicated function that handles a wide variety of different things. Just using bucket logging as an example. So now we're going to pivot to our child account. Up here, notice that on the red bubble there. And this is almost exactly the same configuration. We're going through, we're creating the event pattern here at the bottom account. Again, we're forwarding only the S3 bucket logging enabled event. But here on the target, instead of the Lambda function, because this is our child account now, we're going to forward this event to the parent account. One thing I could do, rather than making this specific, is just forward all events to the parent account, or maybe all events for a service to the parent account. There's no reason this has to be as specific as the one in the parent account. And again, I'm doing this in the console, but this is something that you could, and not just could, but should automate using CloudFormation in your baseline. So now I'm in my child account still. I haven't actually created the rule I wish to target on, so I'm going to create that in config. Again, I can scope this rule down, but I'm just going to apply this to all buckets. Go through. I'm going to let the rule evaluate here. So right now, we have one S3 bucket for the logs, but it's already logging, so it's compliant. So we're going to go ahead and create a non-compliant resource and see what happens. So I'm going to head over to S3 in my child account. I'm going to create a new bucket. Just give it name example bucket. And I'm purposefully not going to set up any other configuration on this bucket. It will be private by default, but it won't have logging on by default, which is what we care about. So I do have the chance to turn it on here, and I'm not. I'm going to hit next. So our bucket has been created. I'm going to head on back over to config. Again, a little bit of Hollywood here. I'm exaggerating by a couple minutes the speed at which this takes place. So we can now see that we have a non-compliant resource. S3 bucket logging has been enabled, or S3 bucket has been created that is non-compliant. So this is an important point here, that within the config console, we can actually pinpoint the resource that was non-compliant. It doesn't just tell us that the environment was out of compliance. It tells us the environment is out of compliance because this resource is out of compliance. But what this has done is we've triggered this, and this has sent a message on the CloudWatch events, using CloudWatch events. It's been picked up by the filter in the child account, and it republished that to the CloudWatch event bus in the parent account. And the CloudWatch event bus in the parent account has a rule that invoked a Lambda function that should be, again, assuming the role back into the child account to turn logging back on. So let's see if it worked. So we're going to go up. Head over to S3. Take a look at the configuration for our example bucket. Head over to properties. Looks like it hasn't been turned on yet. Give it a second. Give it another second. You see that server access logging has been enabled by the Lambda function we created in the parent account. So what does that mean? It means that our config resource, or our config rules, should be back in compliance. And again, this is something that you can do. I mean, this is a pretty mundane use case. I like it because it's easy to follow. But this could be anything. This could be things like firewall rules. Do I have ports open? I could choose to, automatically, close gaps in the firewall if this happens. I could, if something is really out of compliance, I could shut down instances. I could sort of be as aggressive or as light as I wanted to in terms of compliance. And we can see here that the rule has been reevaluated, and our resource is compliant. So again, just to recap with a couple seconds left, AWS config aggregation, AWS config rules. There's a lot of great tools, management tools out there that help you, get the status of all your child accounts, bring them into compliance automatically, get notified about them. If you have any questions, check out the AWS website and take a look at the management tools. And just a couple seconds left, so thank you very much.